call for week 10's session. So, Varun, can you elaborate on your doubt? Like, forum? Oh no, I have not seen that. No, I have not seen that. Yeah. Sorry. Okay. And this is from which week where we started introduction to machine learning techniques, right? Mm-hmm. Week 11. Okay. So that currently we are on week 10. So anyways, it will be covered next week in next Tuesday. But briefly, I can tell you that micro features would be something which are minute. What you can say, special features which can be um, uh, which can come via deep analysis of subject matter. When you're subject matter expert, say you're a cricket fan and you know the minute nuances of the game, so at that time you would know what even the ball speed, what effect it will have on the when you're predicting the shot, right? The angle with which the ball is getting hit on the bat, or and so on. So that all these things are going to have some impact on the shot, or how many runs the batsman is going to score, and so on. So the things which are not implicit but which have a huge impact on our result will be like this, and macro are the apparent features. um, yeah, something. Yeah, I mean the analogy was bad. I mean, yeah, speed of ball is also a macro feature which is very apparent. So micro is where you have to dig the feature out, you have to derive something. Roughly I can tell. Next week we'll cover this in detail. Yeah, we'll discuss more about this. So right now I don't want to go into that because then it will be a digression from today's this week's topic. So today we would be discussing NLP. Yeah. So let's do it quickly, and yeah, move on to next week. Okay. So sorry. Yeah. So quickly, I mean, this week's content is also fairly easy to understand, just like last week. Last week we had finished everything in just 1 hour. Discussion, doubts, and everything was done in 1 hour. So this week also the content is very simple and very similar. So as we are in the era of chat gpt, so I need not tell you in detail for what we need natural language processing, because almost all of us are using chat gpt for some or other thing. um, so the broad usage of NLP could be for information extraction, for summarization of given text and data, then chatbot, asking questions, and having a personal assistant where you describe your problem and you seek answers from the language models. So that is also another application of NLP. Then another useful application for research domain is speech to text, where if we want to analyze the classroom discourse, so for that discourse analysis we'll do the audio recording of the classroom, and we'll try to extract some features into that textual conversation. So for that we have to, like, first step would be to convert that speech to text. So there NLP comes in handy, and even after the analysis of that textual data, where you do a sentiment analysis, or you try to find if there is negotiation going on in that conversation between the students, when collaborative learning is happening, when learning is happening in a group, when teacher has assigned some students to a group, say 2 3 students are forming a group together, and you want to see how they are collaborating, whether it is a good collaboration or whether it is a bad collaboration, are there any misconceptions happening there, or they are sticking to the topic and everything is going on track. So all that type of analysis can be done using NLP. And another feature would be sentence completion. As when we type on our mobile phones, there is a next word which is predicted on our top line of our keyboard. So that is the next word prediction. So likewise we predict the sentence. So if any one of you would be using Grammarly, or what is that, SciSpace, or some other automatic text generation, where you would AI applications which generate text for you. So at that time they would even predict next sentence which you would be writing. The now NLP models, the large language models, have become so intelligent that they would understand what topic you're writing about, what topic you want. So they will even predict the next sentence in itself, not just the sentence completion where the next word is predicted. But now the large language model has brought in the leap in the technology where it has not just limited to text sentence completion, but it has gone to next sentence prediction also, and it will write your entire essay for you also. Nowadays the technology is so advanced. So we will quickly see, before we jump into solving the assignment questions, that what are different concepts of NLP which we need to familiarize ourselves. So first concept is lemmatization, where you would reduce the word to its smaller verb form, where these are different forms of word eating. It's eating, ate, eats. These all can be converted into one verb form, which is eat. Similarly, talking, talk, talks, talk, all these words could be converted into one verb form, talk. So that is lemmatization. Yeah. So stemming is removing all the suffixes and reducing every word. So lemmatization would be majorly related to reducing the word to a verb form, but stemming would be performed on adverbs also, adjectives also. So that was done beautifully. So how we will stem that beautifully word is to beautiful, or just to beauty. So we'll remove all the suffixes and then reduce that word to its minimum form is stemming. Okay. So moving on to another important concept is n-gram. So when we say the sentence completion, when you type something on your phone, on top of your keyboard you get the next word, the next word, so that is predicted using this concept of n-grams. Yeah. So unigrams is, as the word says, unigram, single word. Bigram is set of two words which are occurring one after another. Yeah. So if you say student is sitting in the class, student is sitting in the class. So if in this sentence case, the unigram would be each word individually. Student is sitting in the class, that would be unigram for this sentence. And bigram is set of two words. Student is sitting, sitting in the, and the class, set of two. Similarly, trigram is set of three. Student is sitting, then is sitting in, a set of three words which are coming together. That would be unigram, bigram, trigram, n-gram, and so on. So this n could be any number. Okay. So basic funda which we use here is there's this Markov assumption that says that probability of current word depends on probability of what the previous word was. Okay. So generally in most of the sentences, when we start any sentence with the letter I, which is the most likely next word coming in that sentence? I am. Right. So if I'm typing I, then what is, so the probability that the next word would be am would be very high, like almost more than 0.6 or 0.7. Okay. I am doing this, I am writing, I am going out. So this am word even more than 0.6 probably. Yeah. So this is the Markov assumption, that this word will occur, the word am will occur, depends on which is the previous word, which in this case was I. Yeah. If I'm typing I, the next word will be am. So the same thing in mathematical word is probability of current word depends on probability of previous word. So this P of current / previous word is probability of current word, given that previous word we have already, we know that what the previous word was. Okay. So in this n-gram will play important role. When we are considering set of 2 words, 3 words, then at that time the second word, if we are considering bigrams, then student is. So what is the probability that the next word would be is? If we know that the previous word is student, then we know that the next word would be is. Yeah. So then another concept is this edit distance. Edit distance is when we want to convert, this is to identify the spelling mistakes or similar sounding words. Yeah. So how can we find this minimum edit distances? When we are dealing with similar sounding words, say for example cat and mat. These are two similar sounding words. So what is the edit distance between these two words is when we want to replace, insert, delete or substitute. Yeah. So we are substituting this C by M. That means we are substituting one letter. So the edit distance between cat and mat is 1. Okay. Similarly, summation and sum. What is the edit distance? We have to remove this MATION. So 1, 2, 3, 4, 5, 6. So the edit distance would be 6. Okay, so each action would be the edit distance. Now moving on to another important word, another important concept is bag of words. So we will be doing the two concepts in that, sparse vector and word frequency. So consider these two examples. Students interact with peers in the class and sentence 2 is peer instruction increases the student's interest. So bag of words for first sentence, sentence 1 would be students interact with peers in class. So this is for combined both for sentence 1 and sentence 2. So how do we do that? So students has occurred twice. So we have mentioned the count of students next to that word, students twice. Then interact once, with once, peer twice, because here is peers and here is peer. So that word has become twice. Then in once, class once, instruction increases interest once each. Now another way to represent bag of words is we will assign, so now this is related to sparse vector. So we will make a list of how many words are combined in both sentence 1 and sentence 2, distinct words. So these are the students interact with peer, class, in instruction and increases in interest. So we have this list of 8 words here with us. Then we will see out of these sequence the word students is sentence 1, how we will represent this sentence word with respect to this bag of words is first word is first. So you know this concept of indexing of array. So that same concept we are following it. At index 1 the word is student. No, this is for simplification. It is not that concept. I'm just telling you that we need to consider why this is so long. There are not so many words in sentence 1. So we are mapping this bag of words with the occurrence of that word. So I'll remove this. This may lead to confusion. This is not really the concept of indexing. But we are mapping this word which is occurring in the sentence. Say for example sentence 1, students is at 1, so that is occurring, so we are writing this 1 here. Then there is second word is interact, which is here, so we will write 1. Yes. Okay, then with is third word here in our bag of words, so 1. Then with is done, peer is 4, so 1. Then in, so we generally remove such words into all those smaller words which are not really impacting the meaning of our sentence, so which is we will not consider that word. Okay, then we will move on to the next word, class. So class is, in is already there, sorry, my mistake, in is here but is not part of this. So 1 and class. Then again rest of the words are 0, right? These are increases, interest, instruction, these are all 0 for us, so 3 zeros. So Yeah, so 3 zeros. So this will be sparse vector for that particular sentence. So we have one doubt in the chat box. It is dictionary which is key value pair, so taken with keys. Kind of. Yeah. So we are comparing these key values with the occurrence in the sentence. So whenever that particular word is occurring, then for that particular key we will write 1. So this is the first word in this dictionary, students. So sentence 1 mein first word is student, so it is yes, so that's why 1. When it is no, so last word is interest. Interest is not part of sentence 1, so in that place, in that 8th place, we have mentioned 0. Yeah, so second last word is increases, so increases is not part of sentence 1, so this is 0 over here. Then 0, then which is instruction. Instruction is not part of sentence 1, so here comes 0, but rest of the word class, peer, with, interact, students are part of this sentence, so we have written 111 for those particular words in the dictionary. Yeah, so the sequence in which this dictionary or bag of words has the individual words, we will keep that in mind while coming up with the sparse vector for any sentence. So considering in is optional, because in it is there, it is not there, it is not going to change the meaning of that particular sentence. When we do lemmatization and stemming, we remove some words which are not really contributing to sentiment of any sentence or meaning of any sentence. So in that way we removed in, and it has not really affected the structure of the sentence also, and the meaning of the sentence also. So such words, for ease of analysis, for ease of calculations, we can remove. Like similar word is to, when there is to, we can remove that. So such, the, yeah, so similar words we can remove. Yes, this bow is bag of words. Yes, no, we will not use, because of this stemming. We will remove the suffixes and all these things for ease of this is the basic concept of NLP. We will, when we have to deal with the words, a huge word and their meaning and their thing, so when we have lots and lots of text, like 1,000 words, 5,000 words, 10,000 words, at that time how we will store this? So we perform this lemmatization and stemming, so that these. Hmm. That's what I'm telling. Peers and peer we will use interchangeably for NLP, because we are performing stemming on that. Yeah, students is once only. No, students is also once only. Student and students are not okay. Where? Yeah, yeah, because both are same. Na, students. It will not make much difference, sir. We have just put in as it is. Because we can put it basically. Yeah, we can do it. Yeah, we can do. Hmm. It is interchangeably, like I said, the suffixes or prefixes which will not really change the meaning of our word or sentiment in which we are, the positive, negative, that difference is not brought in because of prefixes or suffixes. At that time, we are allowed to remove them. But when they are adding to the meaning of the word, when they are adding to the sentiment of the word, when they are changing the meaning of the narrative of that sentence altogether, at that time we should not be doing. So here in this case, whether we keep it increases or increase, whether we keep it peers or peer, the sentence meaning is not getting changed, right? The meaning or the sentiment remains the same, so we will not do it. So we can accept it. Yes. Yes. So let me tell you, in NLP, length of the sentence doesn't play any role. We don't care how long our sentence is. That is not going to impact our analysis in any way. So it doesn't matter. What I said when we are allowed to remove is these such words are not adding any meaning. When I say the sun rises in east, if I remove the and if I remove in, sun rises east, isn't, are you able to understand, is that information conveyed that sun is rising in the east? Yes. So that's why we remove that the process is called stemming. Lemmatization is part of that. We reduce the sentence to a shorter number of words so that we can deal or we can perform the analysis more nicely. But anyways, these points are, don't get confused, these points will not be part of your assessment questions. If you look at the assessment questions, such questions are not asked. So if even if it you find it a little bit confusing, don't worry about it. Yeah. So shall we move on to the assignment questions? So if you have any more confusion when we solve the questions, sorry, what happened? Yeah. So lemmatization mein verbs, I covered it when I was telling about this, no? So lemmatization mein what happens is we reduce the words to its verb form. The eating, so grouping will be reduced to just group. For example, inflected will be reduced to inflect, ed will be removed, no? So this is related to verb. Yeah, cut short the words. This is mainly related, lemmatization is mainly performed on the verbs, but whereas stemming would be, extensions are removed. Yes, then it will become it only. Yes. But stemming is not limited to the verb kind of words, stemming could be performed on any word. Like, I said pierce. Yeah, pierce, so it becomes peer. It could be to other words also, but mostly lemmatization would be grouping them together, considering them as one word. But whereas here we will not be performing any grouping. Yeah, stemming is not really grouping. Stemming would be performed on an individual word. Yeah, so that's the main difference, when we consider eating, ate, everything as a one word, but whereas stemming will be reducing that word singularly, considering that. So when we have multiple sentences with us, at that time lemmatization will play role. When there are eating, ate, eats, all these different tenses forms of a verb is happening repeatedly, then we will consider all that set as eat only. So that's why majorly it is done with the verbs, because verbs have same word, different form. The occurrence may be multiple time in different forms in given piece of text. That's why lemmatization is generally a group activity and majorly related to verbs. It could be performed to other words also, but majorly it is dealt in with verbs only. And stemming is generally like everything, verbs and non-verbs, adjective, adverbs, all those words also. When you say something is done nicely, then we will remove the ly and reduce that nicely to only nice. So that will be stemming activity. But when I say Raj ate an apple and Sunita is eating a banana, then ate and eating will be grouped together and will be replaced by eat. So Raj eat apple, Sunita eat banana. So while analyzing, it will be reduced to that. It will be replaced by that. So that's the difference between lemmatization and stem. Okay. So we'll move on to question 1 of assignment, last year's assignment. So which of the following is application of NLP? So we saw in the beginning, first slide of today's lecture was about application of NLP. So can you guess natural language processing where it could be used? Quality assessment, body posture detection, sentiment analysis, and creating question answer database. Yes, sentiment analysis certainly. Quality assessment, yes, because when we are evaluating our questions answers, when we have long question answers, and when we want to evaluate and we want to grade essays, all these activities will be coming under quality assessment. So quality assessment also, sentiment analysis also, and creating question answer database as well. So this is particularly easy task now because of large language models, because of generative AI. We can use ChatGPT to create a question answer database, or create some MCQ questions, and having a step by step solution to a particular answer. So at that time our large language models can help us. So the correct answers would be A, C and D. Yeah? So moving on to next question. Which of the following can be obtained by stemming the word running? Okay, so we had discussion about this. Run, option A, right? Yeah, no confusion here, right? So, so hmm. You tell me what will happen. We discussed lemmatization. What lemmatization does is it will reduce that verb to run, because the base verb form is run. So even if it is lemmatization, the answer would be run only. Yeah, because it is reduced to the base verb form, mostly in lemmatization. So at that point also the answer would remain run only. Okay, moving to question 3. What is the minimum edit distance between intention and execution? So we have seen this also. So can you tell me what is the edit distance? Okay, we seem to have two groups, so let's count. Okay, I'm going to write intention here. 5, everyone agrees, or if there is any? Okay, so we need to replace some set of alphabets. Okay, so now let's count how many alphabets we need to replace. Okay, so this part is same, so we need not replace TION when we want to change intention to execution. So how many letters we need to change? 1, 2, 3, 4 and 5. So what is the edit distance? Now I have counted, you just have to tell me what is the edit distance. 5. Yeah, because why? Yeah, because edit distance definition says how many letters we have to replace, remove or add. All these things, the number of letters which we have to replace, remove or add, will be edit distance. So the correct answer will be this. No, in substitute also and delete also. Number of letters you have to substitute, number of letters you have to delete, everything. How many edits you have to perform on spelling of that particular word. So even substitution is edit, deletion is edit, addition is edit. So we'll now anything. Yeah. So question 4 says I am Sam and Sam I am. I do not like green eggs and ham. So for above sentence, we have to find the value of probability of am given n. What is the meaning of this p am given I? That means we know that this is the previous word. Remember our n-gram discussion. Yeah. So we have to find the probability of occurring of am when the previous word is I. So we have to, now this is the basic probability maths wala problem. Now let us find how many times I has occurred. 1, 2 and 3. Yeah, 3. So total occurrences of I are 3 occurrences. Yeah. And how many times am is occurring after I? 1 and 2. Yeah, this is 1 and this is 2. Here it is I do. So this third time, next word is not am. So we will not count that. Okay. So the count of am is 2. So what is the probability of occurrence of am when previous word is I? Can you tell me now? Somebody already told. 2 by 3. Probability of am 2, total occurrences of I 3. So the answer becomes A, 2 by 3. I did not understand your question. I mean, succeeding and preceding. Reverse. Okay. So probability of I by am. So that is 0 because none. This should be the previous word, right? Okay. 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 Because see, as for my understanding goes, the Markov assumption says probability of current word given there has to be previous word, so we have to count the number of time previous word has occurred. Yeah, so here in this case, let us, if you have to see, we will count how many times am has occurred. So it is twice. Yeah, so am has occurred 2 times and I has occurred 3 times. Yeah. I'm not sure. As far as. Hmm. 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 Yeah, it should be went by 2. Hmm. Yeah, because see, the basic assumption goes that probability of current word depends of probability of previous word. So this the relationship. Yeah. Hmm. Yeah, maybe some mistake. Yeah, you can raise this in forum. Sure. Yeah, it should be 0, right? None of the times that word has preceded the other. Yeah. Yeah. Okay, we'll move on to next question. Which of the following is the Markov assumption? So yeah, we come to this question. So now you only tell me what is the correct answer of this question. Question is what is the Markov assumption? Which statement says? So occurrence of current word X depends on the previous word Y. Current word, future word Y. Anything that can go wrong will go wrong. Yeah. So A. Yeah. Fifth is A. This is 2 by 3 only, na? Yeah, 2 by 3. Okay, good. Question 6. Which of the below word can be obtained by minimum edits from the word effect? Yeah, so you have to tell me which would be which option would require minimum edit. First, yeah. What is the edit distance? What is the edit distance from affect to effect? Only one. Yeah. The rest of the words, their distance is more than one. Emotions, so everything except T, I think you have to replace. Yeah. So and defect also, the this thing is 2, right? Edit distance is 2. So effect is 2, defect is 2, effect is 1. So correct answer is 1. Yeah. So question 7, we have 2 sentences and what will be length of document vector. Okay, so in this we will not leave any word. Okay, even though I said we can remove to the, but right now we will not remove. Okay, so Ram loves to watch movies and Dev loves to watch cricket matches. Okay, so we will list the word. Ram appears only once. Loves appears how many times combined in both sentences? Twice, 1 and 2, right? So we will write 2 here. 2 appears twice, watch appear twice, movies once, cricket once, matches once. Yeah. So how many words we have? 1, 2, 3, 4, 5, 6 and 7. Yeah, I have 8. I'm making some mistake. Yeah, that's what I was looking. 1, 2, 3, 4, 5, 6, 7. Dev is missing. Yeah, Dev is missing. Thank you. Yeah. Yeah. So 8. Option D. Okay. Means we are considering, so we can't always do one sentence analysis and leave NLP, right? We have to consider the paragraph or the document. So document vector is considering both the sentences together. Here we just have 2 sentences, so our document contains the 2 sentence. Bag of words is also very similar. Yeah, no, it is very similar. So this here I have is bag of words, na, BOG. What I have written is bag of words. Bag of words is collection of all the words which are part of those sentences. And document vector is also same. Yeah, count and everything, like how many times it is happening, or list of words, not even count, just list of words can also be bag of words. And document vector will be list of the, somebody had said in the chat box, dictionary with this thing, key assigned. So this is bag of word, and yeah, key value pass, right? So document vector could be first word Ram, second word loves, third word two, fourth word watch, fifth word movies, sixth word cricket, seventh word matches, and eighth word Dave. So this is our document vector. This is bag of words and this is our document vector. Yeah, bag of words will also have how many times each number is occurring. That is again optional. It could be just plain simple list, and here we will plain simple list with number assigned or index assigned to each of them. That would be document vector. Yeah. So I wrote this bag of words because next question requires us to refer to bag of words. Yeah. So okay, they have given separate bag of words. Okay, given the following dictionary of words, first is sun, moon, star. They have index assigned or key assigned to every word. Now, which of the following sentence does have this indexing, like this 1, 9, 12? Yes. But it is it, right? It is it. One is sun. The fourth is east. Yeah, so simple. You just have to match this index and write one after the other, and you get the option D, sun sets in the east. Okay, so moving on to next question, question 9. The answer to the question 8, which is previous question, written in the vector would be. So now there are 12 in our vector, like document vector, there are 12 different words. For this particular sentence, how we will represent it in the form of sparse vector for that particular sentence. So so you keep eye on this sentence, sun sets in the east. I will call out words from our document vector, and you tell me whether that particular index number word is part of the sentence or not. Okay, so first word sun, it is part, is it? So yes. Moon, no, 0. Stars, east, west, north, south, rises, sets, and the, in, yeah, it should be like that. Okay, so 1 0 0 1 and then 4 times 0. So we have to look for 1 0 0 1. This is 1 0 0 1 and this is 1 0 0 1. Then 4 times 0 and 1 0 1 1. Is it 1 0 1 1? Yes. So this seems to be correct option because this is not matching. Na 1 0 1 1 nahi hai. It's 0 0 0 and then 1 1 1. So correct answer is option A. So now you got how you can convert document vector to a sentence का sparse vector. Okay, easy है, simple है. You just have to say whether that particular word is there 1, if it is not there 0, in the same sequence. Yeah, it's like a game. It's easy, it's simple. Then following pairs of words are stemmed to the same form by Porter's stemmer. Porter's stemmer is a stemming algorithm. Okay, so which of the following pairs would you argue shouldn't be combined or compared by stemming? So when we say stemming, they will remove the suffix in any form like ed, ing, ly and so on. Okay, all the suffixes. So now you tell me which of the pairs from ABCD, like abandon, abandonment, absorbency, absorbent, marketing, markets, university, universe. D? No. Great, no confusion there, right? So now concepts are clear. It's simple, and just imagine. So suffix you have to remove. So abandon and abandonment. So this is the suffix, right? At the end, we will remove this ment. Then both words will be reduced to the same form. Abandon. Same for absorbency and absorbent. They have same base word. If you change the form, then they will reduce to the same base word. Similarly, marketing, markets. Both the base word is market. University and universe, they both are not related. They are different words. The meaning is different. So they can't be stemmed to a same word. That's why option D is the arguable conversion. It will not be converted. Okay? Yeah. Okay, so we are done. So just imagine such simple questions coming in exam also and in assignments also. So very, yeah, it's like game, as someone said that 1 0 write karna hai. We have to count how many times each word is occurring. So very simple. So we are done here till the 10 question. We are on the last slide. So yeah. So if there are any doubts, or I think questions were very simple, right? So it was fun assignment, quickly we were able to do it, and very simple. You just have to do the word count. That's it. And the fun part is, earlier there were different tools available to do this NLP, but now we just have to rely on ChatGPT. It will do everything for us, right from sentiment analysis to question and answer generation to quality assessment. You can even paste the answers or paste the paragraph which you have written and ask ChatGPT to assess the quality of the writing. So ChatGPT would do that for you. So earlier there were like different tools available for this task, but right now there are just one tool which would do everything for you, which is ChatGPT. Or even Google Bard. Google Bard is like a personal assistant. Now they have released a newer version last week where you could do you can link the Google apps also. You can, instead of searching through your Google Drive, you can ask Google Bard to look for your drive for the file containing this information. So it will look that up for you. Yeah, so sentiment analysis, we have one doubt in the chat box. What is sentiment analysis? So sentiment analysis is the good example would be Amazon reviews. So you shop on the Amazon site, you open the app, there are reviews written. Okay, so what sentiment analysis done is, it will try to understand the underlying emotion behind, whether it is positive, whether it is negative, whether it is neutral review, whether it is good, bad, about things getting said about the product. So it will divide your reviews according to that. When you are at the back end, when you are the engineer sitting in the back and you want to decide whether to keep that particular product in your website, so at that time you will look at the review, you will try to understand what is the customer sentiment behind it, whether they are happy, whether they are happy with the product, or whether they find the product is not useful. So that is sentiment analysis, as the word says, the sentiment behind that particular text. We're trying to understand that in sentiment analysis. Yeah, sure. So these things also ChatGPT does it for you. You know, you give them the set of reviews, they will give you the division also. These are the particular positive reviews, these are negative reviews. So your product has n number of positive and n minus say 100 numbers of negative review. So the positive reviews are more, then you should keep that product. Okay. Oh, there's nothing ChatGPT cannot do. It does everything. So we have to be. Yeah, NLP will not do that. For body posture detection, you have to do the posture, how you're sitting, you're moving, your hands are moving, your face is moving, that thing. So image processing will do that for you, not the natural language processing. Yeah. Yeah. Yeah, so if there are no more doubts, then we can close this meeting early. Yeah. Okay, sure. Thank you for joining. See you all next week. We are almost to the end. Yeah. Bye. Have a great week. Yeah. Thank you. Stop the recording. I'll end the meeting for everyone and I'll stop the recording here.